Now we're going to look at non-ducted systems. And first we're going to look at a heat pump that is a non-ducted, which is also called a mini split. And the reason it's called that is because we have a heat pump at the exterior like we would for a ducted system that's replacing a furnace. But in this case, there are no internal ducts to be taken advantage of, and so it's often much less expensive, especially for a retrofit, to add heads on the interior, and there can be multiple units inside, which is why it's called a mini split. Each one of the heads is a mini unit, and it can be split between the compressor heat pump at the exterior and indoors. There could be one head. They can also be ceiling cassettes, or they can be multiples, and I have seen units up to 8. But somewhere in the 2 to 4 seems to be the most common. They are connected by cabling from the outdoor unit to the indoor unit. As I mentioned, it's either a head, which is most common, or we're starting to see ceiling cassettes. It is critical that the unit is mounted high on the wall or in the ceiling. That's how they're designed to be. I think it's somewhat beneficial also because it means it's not impacting your wall space for furniture layout, and it can be mounted above an exterior door, as we see in the image to the right, or above windows. And again, heat pumps are powered by electricity, and a mini split heat pump has the same efficiency as a ducted heat pump that is the air-to-air type. Some more images of some heat pumps and the elements. This Fujitsu and Mitsubishi are the two big manufacturers of them. So we have the external unit on the exterior that needs to be hardwired in for electricity. To the right, what we see are two ceiling units that are mounted up into the ceiling, much like a recessed light fixture would be, or a set of 3 heads and a Mitsubishi heat pump. If it is a retrofit, all of the cables, like we see with the Fujitsu to the left, are going to be at the exterior of the house in plastic conduit. If it's new construction, typically all of those conduits are run on the interior in the walls. Here's an example which you saw in your reading as well, as a way of camouflaging that head unit. We also see in the image to the left a camouflage that would actually be more suited for a radiator than for a mini split, as the mini split needs to be high up. But they're both indications that with these types of heating and cooling, as long as you're letting air come through, you can put a grill in front of it as a way of making it less obtrusive. And here's some examples in place of some Mitsubishi ceiling cassettes from their website. So how would you show those mini splits on a floor plan? You're going to show the compressor at the exterior. So it's going to be similar to what we showed for the heat pump compressor for a ducted system, only instead of being fairly close to and connected to an indoor furnace or air handler, we're going to show where the heads are, or the units. So in this case, we're showing that heat pump as the rectangle at the exterior, and then we're showing some boxes on the interior. In this case, there's one in the living room and one in the master bedroom. There could be one in the dining room just as well. With an open plan, it's fairly common to size a unit to cover all of the area. And remember that our kitchen is also going to be generating heat, so we tend not to heat kitchens as often. And then in this scenario, which we're going to look at for some other heating options, because bedroom 3 is rarely used and bedroom 2 is a home office / theater, they don't have any heat pumps shown. The interior units, I should say, the mini split units, but could have a different type of heating solution depending on several variables. Another non-ducted type of heating that we looked at, and again, this is primarily heating, although I have heard of hydronic systems being used for cooling. It is not very common in temperate climates. It has to be a very hot place in order for it to be efficient. So we're going to look mostly at heating. So the hydronic radiant system has no ductwork. It's just pipes in the floor. And those pipes are going to be either copper pipes, or in these images we're showing PEX, which is a type of plastic. The water heaters that are required, usually it's one large heater and it recycles the water. There's often fluid in it as well, so it would be separated from the water heater that would provide our water for dishwashers and our sinks and our laundry and showers and things like that. So the water heater is just has to be heated to 82 degrees Fahrenheit or 28 degrees Celsius in order to give us an indoor air temperature of somewhere around 70-72 degrees. So there isn't a lot of heat loss compared to furnaces, which have to heat air to a much higher level, typically around 120-140 degrees, in order to get it to be around that 70 degrees that we want it to be when it's delivered in our rooms. The images that we're seeing here in the upper left, we're seeing some radiant pipes installed under some OSB floor sheathing. Notice that there's a metallic sheathing installed on the bottom. So the reason why we see the red pipes towards the edge and then we don't see red anymore is because there is a metallic sheathing. That sheathing has been put on so that the heat from the piping is going to radiate up through the floor. Remember that radiant heat travels in all directions unless a reflective surface redirects it. In the lower left, we see some pipes tied to a welded wire mesh, which is awaiting a concrete slab to be poured on top of it, which will be some thermal mass, which will really help make a very even floor temperature. Concrete is excellent thermal mass, and it works very well with radiant hydronic systems. The image that we see towards the middle is a type of floor mat that has been developed. There's several brands. Schluter makes one, but it's orange. But that rubber mat is designed, plastic/rubber mat, to have those knobs in it so that the pipe can be very easily laid within it. And it's giving the height so that when concrete or grout are laid down, that the pipe is not smushed in any way, shape, or form. And then very often a tile floor would go above. So how do we show radiant heat on a floor plan? As we saw in the previous slide, often we'll have two water heaters. We'll have our domestic water heater. Again, this is the same plan that we saw earlier with the kitchen in the upper right-hand corner. We've got our washer dryer and our water heater for domestic water. But then instead of having a furnace in that closet, we have a water heater for our radiant hydronic floor heat. You might have to have some additional notes on a floor plan depending on the interface with the floor system. Sometimes there'll be a series of turnoffs that are mounted onto the wall, for example. And the water heater, as I mentioned, for the floor is set to 82 degrees Fahrenheit. Typically, our domestic water heater is set to somewhere between 110 and 140 degrees Fahrenheit. Another type of non-ducted heating is our electrical resistance. We saw several versions in the reading. This is a recap. The advantage of electrical resistance is they are fairly efficient. They are also one of the least expensive for the upfront costs of the items, which is why we see them in apartment buildings so often and in houses that might have been built at a lower price point, or in remodels where additional heating is required. The left picture that we see here is the Envy wall unit. One of the advantage, Envy is a newcomer to the wall unit field, and they have a cool front. They use air circulation more than the Cadet fans, which are the more common, Cadet being the most prevalent brand in the Pacific Northwest. And so you can put things a little bit closer and not worry as much about it. And then we see some cove heating tucked up in the upper corner between the wall and the ceiling in this bathroom. And remember with radiant heat, which the cove heat is, that radiant heat is in waves. And so having it up and at that angle where it's pointing down at the floor, which in this case is tile, which means it's warming up, at the porcelain, the sink, and you as a person who might be standing using these plumbing fixtures, it's a very pleasant type of warmth to have radiant heat. And they are typically hardwired, meaning they don't have a plug-in and often have a thermostat controlling them. They could even have a remote control associated with them. And there are some Envy units, and it's very nice for retrofitting Envy units that can plug in. So if you have an existing situation And they're very cleverly designed so that they only operate when they're installed, and so if it gets taken off the wall by a curious child or something, even if it's still plugged in, it won't work anymore. Because they are so small, we don't typically show them on a floor plan, but we would note them on an electrical plan where we show our outlets and our light fixtures.